A very similar problem here to the last one, except it's more sophisticated. They're asking us not just for g prime of a certain value, but a couple other things as well. Oops. Let's start with the first thing, g of negative 1. To get g of negative 1, as in any function, you plug negative 1 in for x. So I'm going to go up here, g of x equals this. So g of negative 1 would simply be, replace x with negative 1. G of negative 1 would simply be this integral. What this integral means is find the area under the f curve, starting at 0 and ending at negative 1. That's a little bit quote-unquote backward because we have the greater number on bottom. If I want to flip that around, if I want to make it a quote-unquote forward integral, I can. There's a property that says I can flip those limits of integration as long as I negate the answer. So now I'm looking for the area under the curve, starting at negative 1, ending at 0, and just negate that result. So going to the graph, this is a graph of f. F is what I'm finding the area under. I'm starting at negative 1, I'm ending at 0, I get this triangle. The area of that triangle, base times height, divided by 2, would be 1 times 3, divided by 2, and then negate the answer. So you get g of negative 1 would be negative 3/2. To get g prime of negative 1, that's going to be an awful lot like the problem we just did. We're going to need an expression for g prime. I'm just going to do g prime of x in general. And to get the derivative of g, we're going to have to integrate this integral. That's the job of the second fundamental theorem. So we're going to keep f of something, but we're going to plug in the upper limit. That'll give us not f of t, but f of x. And then we're going to chain on the derivative of the upper limit, which is simply 1. And it's a pretty easy problem from there. I'm going to put negative 1 in for x here, which means I got to put negative 1 in for x here. I literally have f of negative 1. I can go to my graph and say, oh goody, f of negative 1 is simply 0, because that's the y value of the graph when x is negative 1. So I've got that done. I got that done. To get g double prime of negative 1, I take my expression for g prime and go one derivative further down the food chain. So if g prime of x equals this, g double prime of x will go one derivative further. If I differentiate this side to get a second prime, I'm going to have to differentiate this side, and that'll turn f into f prime. Since I specifically need g double prime of negative 1, I'm going to plug negative 1 in for x here, which means I'm going to plug negative 1 in for x here. To get a numeric value, I have to interpret the graph. Is this a graph of f? I need f prime. So I don't want the y value of the function, I want the slope of the function when x is negative 1. So negative 1 occurs on this linear piece of graph, the slope of which goes, let's see, up 6 and over 2. So g double prime of negative 1 is simply 3.